Hello and welcome to another episode of StatLab Statcrunch videos. Today we're going to be talking about section 9.1 and that's going to be regression and correlation. So let's look at the first problem here. For the following data, display the data in scattered plot, that's one. Calculate the sample correlation coefficient and make a conclusion about the type of correlation. They're asking us to use the technology here. I'm going to be using Statcrunch. The maximum weights for which one repetition of half squat can be performed at the times to run 10-meter sprint for 12 international soccer players are shown in the attached data table. So let's go take a look at the data table. Okay, so this is the maximum weight in kilograms and this is the time to run 10-meter sprint for 12 international soccer players. So the sample size here is 12. So what I'm going to do is open it up in Statcrunch. And remember, we are doing regression. So I'm going to go to Stats, Regression. It's a simple linear regression. So I'm going to click on that. And I'm going to pick my X variables. It already tells you what your X is and your Y. And then I'm going to go ahead all the way down. Let me scroll this up a little bit. Where is my Statcrunch? Okay, I'm going to move it and then I'm going to click compute. Once I click compute, the first thing I'm going to click on is this, and this one gives me a scattered plot and tells exactly how my plot is. So I'm just going to scroll down here to see which one meets. So when I look at the scattered plot, my scattered plot looks something like this here. It's going from left to right all the way down, so it's decreasing. So you see that? When you compare both of them, it decreases. So I know this is going to be my scattered plot. So when I'm going to go back, I have to answer the next question, which is going to be the correlation coefficient. And here the Statcrunch simply tells you what your correlation coefficient is, negative 0.902. Rounding off to 3 decimal places, negative 0.903. And because it is negative and it is 0.9, it's a strong negative correlation. All right. Now moving on to the next problem. This is also pretty much the same thing. And this is same as that. All right, now this one is what I'm interested in. So the weights of 6 vehicles and the variability of their braking distance when stopping on a dry surface are shown in the table. Can you conclude that there is a significant linear correlation between the vehicle weight and the variability in braking distance on a dry surface? They gave me alpha is equal to 0.05. Now, so first thing what I'm going to do is I'm going to go ahead and set up my hypothesis testing here. So let me click on my pen tool. Okay, so here they're saying, is there a correlation? So a null hypothesis would be there is no correlation. So if the correlate, this is called the population correlation. If the population correlation rho is 0, that means there is no correlation. And my alternative hypothesis is going to be rho not equal to 0. Once I set this up, it's going to be the exact same thing. If the p-value is less than 0.05, we reject our null hypothesis. When you reject your null hypothesis, that means there is a correlation. If the p-value is greater than alpha, then you fail to reject your null hypothesis. That means there is no correlation. All right, so let me erase this. So in other words, you're trying to say that if, oops, I think I have the wrong window. In other words, you're trying to say that if the R value is greater than the critical values, then there is a significant correlation. Otherwise, there is not enough evidence to conclude that there is a significant correlation. All right, so now let's go ahead and take a look at, let me erase this one. Let's go ahead and take a look at our critical values first. So here, I know it's a two-tailed test, right? because my alternative hypothesis is not equal to rho, so it's a two-tailed test, and my alpha value is 0.05. When it's a two-tailed and alpha is 0.05, I have to divide my alpha into 2, and that gives me 0.025. So that's going to be my alpha value. So what I'm going to do here is I am going to open up my Statcrunch. And remember, I'm going to go to calculators because it's a t-test. I'm going to go to t-calculator to get my critical values. And I have to know my degrees of freedom. So I'm going to go back to see my sample size. My sample size is 1, 2, 3, 4, 5, 6. So my degrees of freedom is always the sample size minus 2. So 6 minus 2, which is 4. And my alpha value is 0.025. And when I look at that, my critical values are negative 2.76445, rounding it off, negative 2.766, and 2.766. So once I know the critical values, my next step is to find my test statistic. Okay, so how do I do this? I'm going to click Statcrunch, Stats, Regression, Simple Linear Regression, my X variables, my Y variables, and click Compute. And when I look here, I am going to look at my test statistic from the slope row, which is 1.573. Okay, my test statistic would be 1.573. So how do I determine if it is significant or if it's not significant? So this is what I'm going to do. I'm going to go ahead and show you that. I'm going to go ahead and draw my critical. Oops, that's supposed to be a curve. So this is my rejection region here, right? This is my rejection region. So this is negative 2.77, and this is positive 2.77. Now I'm going to see where does 1.573 fall. 1.573 is somewhere here, so it does not fall in the rejection region. So I am failing to reject my null hypothesis. Okay, so I'm failing to reject my null hypothesis. When I fail to reject, I would say that there is not enough evidence at 5%. Where do I get the 5% from? Alpha 0.05. Whenever you fail to reject only when you don't have enough evidence. To conclude that there is a significant linear correlation. So what I'm trying to tell technically is that I don't have enough evidence to tell that there is a significant correlation. So probably there is not a significant correlation. That's what I'm trying to say. All right, and let's move on to the next problem here. Pretty much the same thing. Let's check 13. 13 also is the same thing. So let me just do number 13 here. Same thing again, the maximum weights for which one repetition of half squat can be performed and the jumping heights of 12 international soccer players are given in the accompanying table. The correlation coefficient rounded to 3 decimal places, R is 0.737 and alpha is equal to 0.05. Is there enough evidence to conclude that there is a significance between a correlation between the variables? Again, first step, you're going to go ahead and set up your hypothesis, null and alternative hypothesis, and then you're going to go ahead and find your critical values. Remember how you find your critical values? You're going to click Statcrunch, Stats, Calculators, and T. And again, when you do that, you have to keep in mind your degrees of freedom. So I'm going to go ahead and see how many players do I have. 1, 2, 3, 4, 12 international soccer players. So my degrees of freedom is always going to be 12 minus 2, which is 10. Perfect. It's a two-tailed test, so I divide my alpha into 2. And let's see what my alpha is. 0.05. So when I divide that into 2, it's going to be 0.025. And compute, you see that your values correlate here, are the same, your critical values. And then you're going to go ahead and do your test statistic. How do you do that? You're going to open this in Statcrunch, stat, regression, simple linear regression, x, y, and compute. And you're going to get your t-statistic from your slope. And then you're going to see if this lies in the rejection area or doesn't lie in the rejection area. So the easy way to do is simply go ahead and graph your rejection area. All right, this is your rejection area. So this is negative 2, oops, that's supposed to be a 2, 2.28, 2 to 8, this is 2.2, oh god, 2, I don't know why it's not working, but when I see that the t value lies in the rejection area. So when I reject, every time I reject, because I have enough evidence, okay, I reject because I have enough evidence. So what I'm trying to tell you is there is enough evidence to say at 5% level of significance that there is a correlation. Now, in addition to using t-values to decide if you're going to reject or you fail to reject your null hypothesis, you can also go back to your Statcrunch here. Oh, I think I closed the Statcrunch. All right, never mind. Let me go ahead and open that again. Open my Statcrunch, stats, regression, simple linear, x, y, and it's already set up, compute. I'm simply going to look at the p-value here. If the p-value is less than alpha, if this p-value is less than alpha, then I reject my null hypothesis. If this p-value is greater than alpha, then I fail to reject my null hypothesis. So it's the same thing. It doesn't matter if you use your test statistic or your p-value. It's just like using the z-value, the critical values, and using the p-value in the z-test. All right, hope this helps.